Assalamualaikum and hi to our beloved lecturer, which is Dr. Darius. For today, our group would like to present about yield mapping method in precision agriculture for oil palm. Alright, for this introduction part, I will explain about the key concept in modern farming, which is precision agriculture. Precision agriculture is a farming approach that uses technology to manage crop more accurately and efficiently. One of the main tools in precision agriculture is called yield mapping. Yield mapping collects data about crop production across different areas of the plantation using GPS and sensor. In the context of oil palm plantation, this is very important. Unlike uniform crops, oil palm yield can vary a lot of different blocks due to different in soil, topography, and management practices. That's why yield mapping becomes essential. By understanding yield difference across blocks, we can improve productivity, allocate resources like fertilizer more effectively, reduce overall production costs, and increase profit by focusing on the right areas. In short, yield mapping helps us make better decisions for better results.
Okay, I will explain about technologies used in the yield mapping. First, we have GPS, which is Global Positioning System, that provide accurate real-time location data during harvest, while GIS, Geographic Information System, stores and visualize the data in map form. Together, they help to create the detailed yield map showing exactly where productivity is high or low. This information is crucial for identify the problems like poor soil condition and pest affected areas. Next, we use sensors such as load cells and moisture sensor, which are installed on harvesting machine. Load cell measure the weight of the harvest crop, and moisture sensors detect the water content. These readings are collected automatically as the machine moves across the field. They give us real-time insight into crop health and harvest quality. Finally, we have data loggers and mobile device, which plays an important role in managing and storing the information. Data loggers record everything with time and location stamp, while mobile device like tablets allow users to monitor data on site and even do basic analysis. All this data can be transferred to farm management system for deeper analysis and planning. So, by combining the GPS sensor and mobile device, yield mapping help farmers to make a precise decision to improve the crop management and boost productivity.
Thank you to the previous presenter. Salam and good day everyone. Hi, my name is Vivian Yusol. Next, I will continue to present about the data collection methods used for yield mapping in oil palm plantation. So, first and foremost, the most basic method is manual data recording, which is workers manually count the fresh fruit branches and record the weight after harvest. This method is still common in small plantation because it's simple and low cost. Second, more advanced estates use semi-automated system. For example, sensors are mounted on harvest collection machines. These sensors can automatically measure the weight of branches and record of GPS location. It helps to reduce human error and save time during data collection. The third method is using drones and remote sensing. Drones fly over the plantation to capture images of oil palm canopy. The data like leaf color and canopy size help estimate the yield over a large area. It's very fast and useful for large-scale plantation. So in Malaysia, companies like Felda and Samda Bigotry have already started using GPS tools and semi-automated system for yield mapping.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nia Ahmad Shafiq. So I will present about the benefit and application of yield mapping in precision agriculture for oil palm. So for the benefit, first one, improve the productivity. Yield mapping is useful in identifying and specify high and low yielding zones within oil palm plantation. This spatial differentiation enable target management intervention that can enhance overall productivity and resource allocation. Second is early problem detection. Yield mapping technology enable farm to detect potential issues such as pest outbreak, nutrient deficiency, or irrigation irregularities at an early stages. Third one is better decision making. So yield mapping generate critical data driven insight that inform plantation management strategy. This insight allow for informed decision making regarding resource allocation and long-term planning, including yield forecast and economic assessment. For the application of yield mapping in oil palm agriculture, so the first one is the site-specific management. Precision agriculture leverage yield maps to tailor input, including fertilizer and irrigation, effectively managing spatial variability within plantation. Second one is variable rate technology (VRT). Yield maps serve as the foundation for VRT, which enable variable application of agrochemical based on spatial variability demonstrated in yield data. The third one is soil and nutrient management. Combining yield map with soil fertility map allow for refined nutrient management strategies into the specific needs of different field sections, enabling a holistic approach to crop nutrition.
Assalamualaikum and good day to everyone. Myself Pinor Fatina Jo binti Pawatang, and I'll be explaining about discussion for yield mapping in oil palm plantation. Firstly, the harvest cycle is long and irregular, making it hard to compare yields spatially over time. Unlike seasonal crops, oil palm yields fluctuate across several years. Secondly, data integration is complex. Yield maps must combine various inputs like harvest weight, soil, and weather data, and tree age, often stored in different formats and resolutions. Sensor limitations are also an issue. For example, standard GPS lack the vertical accuracy needed for proper terrain mapping, which affect drainage and fertilization planning. On top of that, cost and technical barriers hinder adoption. Many estates hesitate to invest in drone, AI tools, and sensor-equipped harvesters without clear return on investment. However, solutions are emerging. Machine learning models like Random Forest and XGBoost have shown high accuracy in predicting yield based on soil and climate data. Drones with multispectral cameras now enable tree-level nutrient mapping, while AI can even detect individual palm trees from satellite imagery with over 93% accuracy. To succeed, estates must invest in better GPS system, pilot smart tool and selected blocks, and train their workforce to handle new tech. Long-term, this will lead to smarter input use, improved planning, and ultimately higher yields.
To conclude, yield mapping is a powerful method in precision agriculture, especially for oil palm plantation. It helps to detect yield variation across different blocks by using modern technology like GPS, GIS, load cell, and even drone. This is allowed farmer and plantation manager to manage resource for efficiently, apply fertilizer accurately, and make better planning decisions. With this method, we can reduce production costs, improve yield prediction, and increase overall productivity. However, there's still some challenges. For example, oil palm yield can change every year due to variation factor like weather and trees age. Also, the integration of different type of data can be difficult, and GPS accuracy is sometimes limited in hilly area. Even with this limitation, yield mapping gives us valuable insight and play an important role in sustainable and data-driven management of oil palm plantation. It's a step forward in making agriculture smarter and more efficient. That's all from me. Thank you.